So we've seen with scalar multiplication of a matrix, we just simply multiply each of the elements of that matrix with the scalar multiplier. And what we get is just a multiple of the matrix that we started with, but dimensions of the matrix doesn't change, so it's a relatively simple operation. Now with matrix multiplication, it's a little bit more complicated because we can actually get a matrix of a certain dimension, multiply it by another matrix with different dimensions, and come up with a new matrix of even different dimensions. So matrix multiplication is also called matrix product, because the product of the operation between these two matrices is another matrix. And I can probably explain that a lot better with a real life example. So let's suppose that we are running a fruit stall, and to make it easier for the customers when they're buying their fruit, let's pack them into different packs. So we've got 4 different packs here. We've got a basic pack, a variety pack, a deluxe pack, and a super pack. And as you can see, the contents of each of these packs are as follows. We've got, say, in the basic pack, we've got 10 apples, we've got 8 oranges, 5 bananas, 3 peaches, no mangoes or pineapples to keep the cost down for that pack. And the contents for the other packs you can see here. So we have this table. Let's write this in a matrix form. We'll call it the P matrix for pack, and we'll simply populate the matrix with all the numbers in the rows of that table. Okay, so we've got our pack matrix. This table here represents how many packs we sold in the months of July, August and September. And we may want to know this information so that we can prepare for next year. So for example, we want to know how many apples we need to buy. We want to have an idea of how many apples that we need to buy in order to satisfy the buying habits of our customers for next season. So let's populate the matrix M for month with the data in each of the rows of this table. Okay, so we have the P matrix, which is a 4 by 6 matrix, so 4 rows by 6 columns, and we have the M matrix, which is a 3 by 4 matrix, so 3 rows by 4 columns. So let's suppose that we wanted to quantify the total amount of apples that we needed in July, given that we sold 9 basic packs, 8 variety packs, 6 deluxe packs and 5 super packs. The total amount of apples that we needed to make up each of the packs that we just sold. So in the P matrix, the first column represents how many apples are in each of the packs. The first row of the M matrix represents the amount of packs, each of the packs that we sold. So to get the total quantity of apples, I sold 9 basic packs, and there are 10 apples in those. I sold 8 variety packs, and there are 8 apples in those. We sold 6 deluxe packs, and there are 6 apples in those. And we sold 5 super packs, and there are 6 apples in that pack. So then we can add them all together to work out the total quantity of apples needed in July. So we got 90 plus 64 plus 36 plus 30, and this equates to 220 apples in total for the month of July. Alright, now I can work out how many oranges we needed in the month of July. We follow exactly the same process. I just take the product of the first row of the month matrix by the second column of the P matrix, which represents how many oranges were in each pack. So we sold 9 packs of the basic with 8 oranges each, 8 packs of the variety with 7 oranges each, and so on and so forth, and add them all together, and it totals to 200 oranges in July. So we can now start populating the quantity matrix. Let's call this new matrix Q for quantity. So Q will be the product of the matrix M by the matrix P, and the data we have already for the first row is we had 220 apples in July, we had 200 oranges in July. To get the next element of the first row in Q, we again get the product of the first row of M by the third column of P, which will quantify how many bananas we needed in July. And I've already pre-calculated this to be 159. And sorry, I've made a mistake here. This should be 5 by 6, so which means that we only have, instead of 200 oranges in July, it's 194. So as you can see, matrix multiplication can be quite a tedious process, and it's easy to make mistakes, and that's why for large matrices we tend to use calculators and computers. Okay, for the remainder of the first row, if we do the exact same thing for peaches, mangoes and pineapples, find we needed 131 peaches, 51 mangoes and 35 pineapples. Now if we take the product of the second row of the M matrix by the columns of the P matrix, we'll get the quantities of all the fruits for the month of August. So we sold 218 apples, 193 oranges, 167 bananas, 140 peaches, 56 mangoes, and 37 pineapples. And finally, for the quantities in September, we multiply the third row of the M matrix by all of the columns of the P matrix. So thus we sold 202 apples, 173 oranges, 123 bananas, 92 peaches, 28 mangoes, and 21 pineapples. So as you can see, we've multiplied matrix M with matrix P to form matrix Q. Matrix M is a 3 by 4 matrix, matrix P was a 4 by 6 matrix, and the new Q matrix is a 3 by 6 matrix. So as you can see, the new matrix, the product matrix, doesn't have the same dimensions as the originals, but it does have the same number of rows as the M matrix or the first matrix, and it has the same number of columns as the P matrix or the second matrix. So matrix multiplication is often written as follows. Alright, so this denotes the Q matrix. So for any given element of the Q matrix, it is given as the sum of the products of the elements in the ith row of the M matrix and the jth column of the P matrix. Sorry, this should be a P, not a B. Alright, so finishing up, there is one very important condition that has to be satisfied before we can multiply two matrices, and that's called conformability. And what that means is if I want to multiply matrix A, which has dimensions, let's say n times m, and I want to multiply it by matrix B, which has dimensions m by p, what conformability means is that the first matrix has to have the same number of columns as rows in the second matrix. So in our example, we had a 3 by 4 matrix and a 4 by 6 matrix. So we had the same number of rows in the first matrix as columns in the second matrix, and that has satisfied the condition of conformability, and the resultant matrix had the dimensions of the number of rows in the first matrix by the number of columns in the second matrix. So generally, the resultant matrix would have the dimensions n by p. So before I finish, would this work then if we reversed the order? So if we were to multiply the matrix B by A. So again, if the matrix B had the dimensions m by p, and the matrix A had dimensions n by m, we can see that here p and n are not equal. So this order does not satisfy conformability. So therefore, multiplication is not defined for non-conformable matrices. And that segues into our next video, where we'll explore some of the properties of matrix multiplication. And the first one is that matrix multiplication is generally not commutative. So it doesn't satisfy commutativity like multiplication of just numbers. Okay, that will do it for this video. If you found this information helpful, please like, share and subscribe to my channel. And I would really appreciate if you can make a small donation through my PayPal or through my channel page, as these videos take a lot of effort for me to produce, and with your help I can make more of them and serve more math students into the future. Best of luck with your studies, and I'll see you on the next video.